read again was it was 3C, and it's also June 2005, and it's a metal surface. So I'll draw our metal surface, and our metal surface has a work function of 2.1 electron volts. Then photoelectrons are emitted when light of wavelength 420 nanometers is incident on the surface. So our photons of light have a wavelength equal to 420 nanometers, and that's when photoelectrons are emitted. So we need to find what the speed of these electrons are. That's what the question was asking. Okay, so the important equation here is the energy of our photons of light, the energy of those minus the work function, which we already have here, is going to be equal to the kinetic energy of the liberated electrons, and then the kinetic energy is given by half mv squared, as it is in all cases for kinetic energy. So the first thing we need to do is find out the value of our kinetic energy. So using the same method as we used previously in the last question to find our frequency and therefore energy of our photons, we can say that frequency is equal to the speed of light divided by the wavelength. So that's going to be 3 times 10 to the 8 divided by 4.2 times 10 to the minus 7, or 420 times 10 to the minus 9. So 3 times 10 to the 8 divided by 4.2 times 10 to the minus 7 is going to be equal to 7.14 times 10 to the 14 hertz for our frequency. And then we know that E is equal to HF, and then Planck's frequency is 6.63 times 10 to the minus 34 times our frequency, which is going to give us a value of 4.7, we'll just say 74, times 10 to the minus 19 joules. Okay, so then using this equation next, our energy minus the work function, to find our kinetic energy. Our work function is 2.1 electron volts. To get that into joules, we're going to have to do 2.1 times 1.6 times 10 to the minus 19 joules, and that's going to get us 2.1 times 1.6 times 10 to the minus 19 gets 3.36 times 10 to the minus 19 joules. Okay, so we've worked it both out in joules, and the reason for doing that is joules is the standard unit used to measure energy. So a joule is equal to kilograms meters per second squared, I think. Yeah, it's something along those lines. It's potentially kilogram meters squared per second squared, but essentially once we plug in the units, you get for mass, which is kilograms, and then velocity, which is meters per second. Yes, so it would be kilograms meters per second squared, meters squared per second squared. Sorry. Anyway, where was I? Oh yes, so then what we want to do is we need to find it in joules, and that's just why we find it in joules. Sorry, I went off on a bit of a tangent there. So what we do is our energy of the initial photons, which is this energy here, minus the work function energy, which is this energy here, and that's going to give us our energy kinetic, the kinetic energy of the liberated electrons. So that's going to be 4.74 times 10 to the minus 19 minus 3.36 times 10 to the minus 19, which gives us 1.38 times 10 to the minus 19 joules. Okay, but we can't stop there because we need to find out what the maximum speed of the electrons emitted was. So the mass of an electron will be given to you in your formula sheet, and that's 9.11 times 10 to the minus 31 kilograms. And then so energy kinetic is equal to half times mass times velocity squared. So the 1.38 times 10 to the minus 19 is equal to 0.5 times 9.11 times 10 to the minus 31 times our velocity squared. So if we divide through the whole equation by our half m, our half mass, then we'll get our velocity squared. And then if we take the square root of that, then we will find the velocity is equal to the square root of energy over half mass, and that is going to be equal to the square root of 1.38 times 10 to the minus 19 over 0.5 times 9.11 times 10 to the minus 31, which should come out with a value of roughly 550,000 meters per second, or 5.5 times 10 to the 5 meters per second. And that is the speed of the electron once it has been liberated from its metal prison, if you will, or the energy shells of the metal, with the work function of 2.1 electron volts. So those are just a couple of examples. I'll send you through a detailed explanation. I'll probably link it just on YouTube. I probably won't put this on YouTube, but I'll link that on YouTube so that you can go through and have a bit of a recap, once you get towards exam time, or now if you feel like it. All right, cheers.